of the derivative of the entire expression. This is always positive. I'm not going to waste my time. So plug in 0 and tell me the sign so I can put it here.
Negative?
Yes. Plug in 9 and tell me the sign.
Positive.
That's it. So what type of point is this? Remember we said when the tangent has a negative slope, the function does this, and when the tangent has a positive slope, the function does this. What type of point is 4/9, comma, I'm going to find the y value in a minute. What type of point is 4/9, comma, this number? A relative? Min. Very good. So I'm going to plug this value in the function. I know already it's 0. We already said that. I'm going to plug this function in here, and then I'm going to identify the fact that according to this has to be the case. So this will be definitely a number below 0. It has to. So I'm going to plug in the function. Let me share my screen. And I'm going to plug the function in. And the original function was, where is the original function? The original function was t to power 3/4. And then minus 2 t to power 1/4. You know I love my parentheses. Okay. See what I did? See what I did? I'm glad I didn't plug it in and then scream at myself. So 3 divided by 4, down from there, please, minus 2, t, and the power is 1/4. Okay, very good. It looks fine now. And we want to plug in 4/9. We are expecting a negative number. It has to be negative 1.089. So this is a relative minimum and also an absolute minimum. The function starts at 0, comes to the absolute minimum, and goes to positive infinity. What type of point is 0, 0? Is this a point of extrema? Point of extrema. By that we mean, is it max or min? Max, min. Point of extrema. Extremum, extrema, plural. What type of point is 0, 0? It's at the end point of the interval. It can only be an absolute or nothing. It can be absolute min or absolute max.
Absolute max.
Because it's a value, we can plug it in to see that their value is higher than it. If they're not, then that would be an absolute max. So let's go back. Oops, I am already there. I mean that. Okay, so I'm going to plug in 30. Okay, I'm going to plug in 5. So the numbers are larger than 0. When I plug in, I didn't plug in anything. The numbers were there already. So since when I plug in numbers, I get a value larger than 0, 0, 0 cannot be anything. So this is nothing. No local max or min because it's at the end point of the interval. The function doesn't exist on this side of 0. It cannot be an absolute because minimum because this value is smaller than it. It cannot be an absolute max because the function goes to larger values on this side that are higher than 0. So let's summarize what we did, because it was a long situation. We were given a function. We were in this problem, we were only asked to find the critical numbers. We have to start with the domain. Why? Because we may find critical numbers from h prime or the function being undefined, but how do I know if it's a critical number if if the function doesn't exist here, then that's not a critical number. That's why I have to start with the domain. Then, after I found the domain, I found the derivative. After I found the derivative, I analyzed the derivative. When I set it equal to 0, I got 4/9. When I said, can this be undefined? Yes, I got 0. So the function, because it's defined at 0, these are two critical numbers. And now the question is, since we are here, we are working on this function, are these max min or not? They don't have to be. If the derivative does not change sign, this point is nothing. If I have positive, 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 positive everywhere, nothing. If I have negative, negative, negative everywhere, nothing. But it changes sign, and it changes sign in this sequence. Negative, positive. So this must be a relative minimum. It turned out to also be an absolute minimum. So we put those two critical numbers in this table. Please start getting used to this table. This is a crucial table moving forward in chapter 4, in which we have the first derivative, the function in the middle, and the second derivative shortly. We'll add it in. Right now we're discussing the first derivative and critical numbers, max, min, increasing, decreasing. Now I can say a lot about this function. Between these two, it's decreasing. Between these two, it's increasing. It has a relative minimum and also an absolute minimum. It doesn't have absolute max, it doesn't have relative max. And this all these come from the first derivative. Increasing, decreasing, a relative min, max, or absolute min, max. I know it was a long problem, but it's the first one that we looked at, and I had to show you all these steps. Now let's choose another. So this was a weird one because of these exponents, and it always requires a lot of work with fractional exponents. And after we choose another, I'll let you choose, I would like to look at finding absolute max, absolute min. For the absolute max and min, we are given an interval. Look at all these. They all have a closed interval, okay, for the absolute max, min. So let's choose another from here to find critical numbers and whether they change into max, min or not. Any preference? I'm on page 6. Any preference? Let's move away from rational exponents for a moment. Take a deep breath. Unless it's up to you. Anyone would like to choose, or I will? No one? I want to see this one. It's interesting. So g of x, what is it? 47? G of x, x squared natural log x. Is that okay with everyone? You want to choose another? I'll wait. Is that okay?
Yeah.
Perfect. The same question, same thing. I'm asked to find critical numbers. Where is my starting point? Always. Anyone? Is anyone there paying attention, please?
From the domain.
Yes. Can anyone give us a domain of this function? Anyone?
Is it all real numbers?
Let's review the graph of natural log, please. Natural log is not a friendly function. We wish it were, but it isn't. Anyone would like to try it again? 0 has a vertical asymptote at 0, 0 to infinity with open parentheses. Good. So in step number 2, we have to find g prime of x. It's the product rule. First function prime plus x squared times 1 over x. So then g prime of x equals 2x natural log x plus x. We will definitely factor out x, 2 natural log x plus 1. In step 3, we know critical numbers come from 2 sources. It doesn't matter the order you check. You can say g prime of x undefined and g prime of x equals 0. It doesn't matter. So now let's look at this function. Where is this function undefined? Well, it's undefined at the same values as the original function is. So I will not find critical numbers coming from undefined. This is undefined for negative numbers and 0, but so is the function. So no undefined situation. Now this is a product. What are the 2 options here for this to be 0? There are 2 possibilities. One possibility comes from this. How much?
X equals 0.
Right, which is not the case because the function is not defined at 0. This is impossible. And the second one is 2 natural log x plus 1 equals 0. This is the only chance. This is not possible. This is not possible because it's not in the domain. So this is the only chance. I move 1, divide by 2. How do I proceed? Anyone remembers what type of equation this is and how do we solve it? First of all, let's establish what type of equation is it. How do we call it?
Logarithmic.
Log equation. Perfect. So now the double equivalency says to change this into an exponential equation. Anyone remembers? First of all, I don't see the base. Is there a base in there? If there is no base, I don't know what to do next. What is the base here?
10.
LOG has base 10.
Base E.
Base E, very good. It is base E, we don't write it. So E raised to this equals this. E raised to negative 1/2 equals x. So this is x equals e to negative 1/2. Yes, I would have to approximate this. I have no idea what this means. It's basically 1 over the square root of e. I don't know what that is. So I'm going to put in the calculator. I'm going to share my screen and put in e. Where is my e? Okay, I see it. To negative 0.5 and close and press enter. 0.61. So 0.61. So I know that this is the critical number, the only critical number that this function has. Is this a max-min? If it has no critical numbers, it will have no max-min. But this is a max-min? No clue. Not until I study the sign of the first derivative. That will tell me whether it's a max or a min or none of the above. So please use this table. So we have g prime of x, and we have g of x. Again, the domain is, if the function is not defined at 0, its derivative cannot be defined at 0. Let me see here. So see, I did not extend because the function was defined at 0, but its derivative was not. Okay, but here, all the way. 0.61, 0 here. I will plug it in the function in a minute to find that. We can do it right now, so we can put the value in. We need that always. We always need that. Sorry, what was I doing? So 0.61 squared, and then natural log of 0.61. So I got negative 0.2. Okay. Perfect. So now, here is the derivative. I'm going to copy it one more time because it's easier if I have everything here. So g prime is x to natural log x plus 1. Remember, this is 0 to infinity. Don't waste your time with x. There is no point. It's always positive. This quantity is always positive. Don't waste your time to plug in quantities that are always positive. So I'm going to plug in 0.5 between 0 and 0.61 in here to see the sign of the derivative. And then I'm going to plug in 10 to see the sign of the derivative here. So that's the reason why I always like to have the function in, so I don't have to write it several times. So we had x, but there is no point to put in x. I only need to natural log x and then close and plus 1. That's all I need. So I'm going to plug in 0.5, and I'm going to plug in 10. I only care about the sign. I don't need any number. So negative and positive. So then I have negative and positive. I know it must be this. What I should determine here, in this point right here, I should determine the limit. Limit as x approaches 0 from the right of the original function. X squared, natural log x. Can anyone tell us what that is? And the thing is that this is a situation in which this approaches 0 and this approaches infinity. So this is one of the indeterminate cases that we did not get to. We will in this chapter. So we looked at indeterminate cases. Indeterminate cases. We had 0 over 0. We had infinity over infinity. We had infinity minus infinity. This is another one. And no, you cannot say that this is 0. So I'm going to leave this alone. We can graph and find this, but we cannot determine this just yet. What we normally do is an algebraic manipulation. This is not a difficult situation. There are others, so there are 3 more, so the total of 7. This is not a difficult situation when we get to it towards the end of chapter 4, towards mid chapter 4. I will explain why we're going to change this into natural log x over 1 over x squared as x approaches 0 from the right. It's the same thing. But now this is infinity over infinity. So maybe since I showed it, well, let's finish it up. So we know L'Hopital's rule, right? But L'Hopital's rule is not applicable in 0 times infinity. I have to change it into this or this if I can, and I can. So now when I differentiate the numerator, I get 1 over x. Remember, the denominator is x to negative 2. When I differentiate this, I get negative 2 x to negative 3. So this will be negative 2 over x to the third. I want this to look like a power. And then when I flip, you will see we get 0. So this will become limit as x approaches, but not because 0 times infinity you can conclude that it's 0. No, you cannot. So this will be negative 1/2 x cubed over x is x squared. So this is 0. So then this is 0. So now it all makes sense. From approaching 0, down to 0, negative 0.2, up. So this is indeed the relative min and an absolute min. I didn't mean to choose 2 with absolute min, but it just happened. You can skip this piece because we're going to get to it in section 4.5. 4.4, 4.5. So we are going to continue and have all the 7 indeterminate cases listed.